Hi, Addie. Welcome to today's lesson. We are going to do lesson number 28 on page 116 of your book. And today's lesson, I really like it because we're going to talk about fractional parts of numbers. And when you learn it sort of this way, it's going to make problems that seem difficult easy for you to do. So I think you're going to like that part. It's not my favorite, I have to say, but I like being able to know how to solve those problems in sort of an easier way. So I do like that. And then we're going to talk about functional notation. This one I do love. I love functions. Functions are really cool. So functional notation means what are the words that we're going to use to describe functions or the terminology, things like that. So I think you're going to like it. I think it's going to be kind of fun. I'm excited. All right. I got this for you to look at, just kind of a deep thought. When my daughter was 7 years old, she once interrupted a bedtime story to tell me, in a pie eating contest, it doesn't matter if you win or lose because you get to eat pie. I think about that a lot. Maybe that is actually a really deep thought. I don't know. Take a little pause here, stop to think about it. Let me know what you think. All right. Let's start with the fractional parts of numbers. So fractional parts of numbers. So when you multiply a number, let's say you take a number like 48 and you multiply it by a fraction, we say that the result that you get is a fractional part of the number. So for example, if you multiply 7/8 by 48, the answer that you're going to get is 42. Isn't that kind of cool? Okay, so 7/8 of 48 is 42. You could do this like I'm multiplying it by a fraction like that, and you'll end up getting that answer. So if you want to check the math on that, you can. But that's kind of cool. All right, so if you use words to sort of describe this type of problem, what it's going to be is 7/8 of 48 is 42. And these are going to be important words here. So the fraction, you start with the fraction, and the multiplication means of. Okay, so just think of that as of. And then of 48, this is the number that you're going to take a fractional part of. And then the answer, you can think of the equal sign as is 42. So when you say it in English, these words are going to become important. A fraction of is. Okay, think about that. And then we're going to write it like this. A fraction of, that's where you multiply, is. Okay, so think of this as kind of like, this one I want you to remember. I'm going to put a thought cloud around it because I want you to sort of memorize this. Because this, believe it or not, is going to be a way for you to start solving really challenging problems that I'm going to tell you 90% of your friends are going to get these wrong because they're complicated to think about. But if you know this little equation, you're going to be in that top 10% that does not get it wrong. For sure, you already would be. But the F stands for fraction. So that's what that is. The words of and is are sort of parts of that statement that we used in the previous example. And we're also going to use some other variables like this. Okay, so when we write it as an equation, we're going to use some of these variables. So Wn is going to mean what number. Okay, Wf is going to mean what fraction. WTF, oh wait, that's not one of them. No, just kidding. Just kidding. So just Wn is what number, Wf is what fraction. Okay? And in these types of problems, we're going to avoid using the variable x because they said that's kind of a meaningless variable. So let's jump into an example and see how we can put this to work. And I've got some little elf GIFs for you today so we can have some fun with that. You can remember that play you saw. All right, example 28.1. The question is 3/4 of what number is 69? All right, so what number, remember this is one of the variables. So we're going to make that Wn. Okay, so in this problem, the fraction is 3/4. The word of is what comes before what number. And then the word is associated with 69. So we're going to make the replacements. The first thing I'm going to do, I'm going to write okay, so F times of, so of what number? And then is. So if you rephrase it this way, 3/4 of what number is 69? So they want to know 3/4 of what number, this is what they want to know, is the 69. Do you get it? So you just have to make sure to put the numbers that they give you into the right places. A lot of your friends would wrongly put the 69 there in the place of, but that's not where it goes. It goes in the place of is, because it's is 69. So a fraction of what number is 69. So we would write it like this. Okay, once you've got it to here, it's easy. It's super easy. So we just have to solve for Wn. So how do we solve for Wn? Easy peasy. We just need to get rid of the 3/4 over here. How do you get rid of a 3/4? Well, one way is to multiply both sides of the equation by 4/3. Okay, and then that makes it easy because this all cancels out. And what you have left is Wn is equal to 69 times 4/3. And then you can just do the math on that. So what you do is you do, you could think of it as multiplying two fractions together, so like that. But I just kind of do that in my head. So 69 times 4 and divide that by 3. You might need your calculator. And the answer you'll get when you do that math is 92. And then what I like to do is go back to that original problem and see if that makes sense. 3/4 of what number is 69? So if there's like 92 questions on a problem and you get 3/4 of them right, you're going to get 69 out of 92. So that kind of makes sense. Those numbers make sense to me. So we got it right. Cool. Let's do example 28.2. You are very good at decorating. Was that part in the play? You are very good at doing math. All right, let's keep going. The question is, what fraction of 40 is 24? So I'm going to write the equation. Oh, let's write it with something that will stick. All right, so fraction times of is. All right, so what this time they're saying what fraction? So we're going to be solving for this f, okay? So what fraction of 40? So where does the 40 go? I'm going to make this because they did this. Let's do this. What fraction? That's what we're solving for. Times of. So of is what fraction of 40? So I'm going to put the 40 there. Is 24. So I'm going to put 24 in the place of this is. Make sense? All right. Now that if we get it to here correctly, you're going to get it right. Right? I mean, you just have to get it to here. That's the tricky part of these problems. That's where your friends are going to mess up. So let's just solve for WTF or WF, just kidding. Okay, so 40, divide both sides by 40. That makes it easy because that cancels out. And then what you're left with is WF equals 24 over 40. And all you have to do is simplify that fraction, and that turns out to be the same as 3/5. So if I go back and put that in the original, it said what fraction of 40 is 24? So if you have like a test where there's 40 questions and you get 24 right, what fraction did you get right? You got 3 out of 5 right. Okay? You're going to do better than that. That's not even, that's like, what is that, 60%? No, that's not even acceptable. Okay, here's Elf jumping across the street. He's so funny. Okay, example 28.3. 2.5 of 240 is what number? All right. So this time the fraction is written as a mixed number. So don't let that confuse you. It's still a fraction. And then you can see that of is going to associate with 24. So that's of. Is going to associate with what number. So we're going to be solving for is, and we're going to make it what number. So once you do that and you make those substitutions, it's going to be easy. So fraction times of is. This is how you solve all of these types of problems, right? So the fraction is 2.5. So I'm going to write that here. Of 240, so instead of the of, sorry, I'm going to write 240. And instead of the is, I'm going to write what number, because they called it what number. That's what we're solving for. So this is easy because all you have to do is multiplication. I would change the 2.5 to a mixed number, so to a fraction. So 2 times 2 is 4 plus 1, and this is going to be 5 over 2. And then you can just do 240 times 5 over 2, which is the same thing as making that a fraction, like 240 times over 1 times 5 over 2. So 240 times 5 divided by 2. And that means that the answer that you're going to get if you do that math is, what is it going to be? 600. There you go. That's the correct answer. So once you plug things in correctly, you'll be able to do all of those problems. They get a little tricky, so be careful because sometimes they want you to mix up the of and the is, okay? So just remember that equation. All right, these happy elves are happy because we are going to jump into functional notation. I love functions. These are fun. Okay, let's look at this algebraic expression, x plus 2. And you know that when you have an expression like this, it has exactly one value for anything you choose as x. So if you choose x is 5, then there's only going to be one answer, and it's 5 plus 2, which is 7. Okay, and if you choose a different x, you're going to get a different answer, but there's only going to be one answer for every one thing that you plug into the equation. Okay, so they want to make this point. So if you replace x with 5, so when x is 5, the answer that you're going to get is 5 plus 2, and you get 7. What if x is 0? The answer that you're going to get is 0 plus 2, or 2. What if x is negative 75? The answer that you're going to get is negative 75 plus 2 is negative 73. Okay, so you'll get one specific answer for everything that you put in as x. Now, if there's an expression like this where there's only one variable, x, and there's only one answer or one value for anything that you plug in as x, you can say that this is a function of x. Since x plus 2 has only one answer, you can say that it's y, or y is equal to x plus 2. All right, so and then you can sort of do the same thing, and they kind of go over that again, and they say, what is y when x is 5? Well, we already did that. It's going to be 7. What is y when x is 0? We already did that. It's going to be 2. What is y when x is negative 75? And then y, you'll see y is equal to negative 73. So you could say it as y, but mathematicians have kind of decided instead of y, we're going to say that this whole thing is a function of x. And when you choose to put in something for x, that means it's a function of x. And instead of y, they call it f of x, or a function of x. And this is important. And I think this, have you noticed in my handwriting that whenever I write f's, like, I don't know, like if I write my name, Jennifer, that I write it like that? Look at that f. I just made the connection last night when I was looking at this homework assignment for you, that I think I do it because of functions, because that's how they write the f for function of x is x plus 2. So what does a function mean? How does that change anything? It doesn't really change it. You're still going to plug in a value for x and you're going to get one answer, but they kind of think of it as, look, a Christmas tree. I kind of think of functions as a machine. Okay, so check this out. I drew this. This is not in your lesson, but this is how I think about functions. the function is, oops, I didn't write that very good. A function of x is written on the machine. This is the machine. And you might have a different machine, but whatever. And then you're going to take some value for x and you're going to throw it into the machine. And the machine will jiggle and make noise, and it's going to spit out an answer, which is going to be a function of x. So for every x that you put in, and it can be a different x, you might put in it's like putting in a quarter or a dime or a penny, and you're going to get something different, right? You're going to get f of x. But whatever you get depends on the machine that you put it into. It depends on the function, okay? And you don't have to have the same machine, right? It can be something called f of x, which is this machine. It could be g of x. This is a different function. You're going to get a different answer. You can tell because that equation is different, right? That's a different function. And this last one is h of x. And it's just a different function, or it's an h function. And so the functions have names just like the different machines. And once you name it, then you kind of know based on the equation that it's a function. You're going to get one value, one answer for everything that you plug in. Okay, hopefully that's not too complicated. So for example, if you take a -3, and which machine are we going to put it into? We are going to put it into this machine. If you put it into the h of x machine, or the h function, what's going to happen is you're going to get one answer spit out. So we would have to figure out what that is. So it would be written like this: the function h of x, where x is equal to -3. And the way you write that, like mathematically, you would say h of -3, because that's the number you're plugging in, or you're putting into the machine, 2 times -3 cubed minus 3. All right, and then you just do the math. So what do we have to do? Well, we know from order of operations that we have to do the exponent first. So -3 times -3 times -3, that's 3 negatives. So it's going to be 27. I just brought that 2 down, -27, because it's a negative. -3 times -3 times -3. Yep, it's going to be -27. All right, so we did this first. We write it there, and then everything else you just kind of bring it down. So that -3. So this is h of -3. This is not something where you have to solve for h. This just means you plugged -3 into the function of h. And so the answer is written like this, h of -3. If you do the rest of the math on there, the answer that you're going to get is 57. And that's where you stop. H of -3 is equal to -57, because that's functional notation. That tells you that you've replaced x with -3 and you put it in the h function. Okay, so h of -3 equals 57 is the answer. And that's how you would say it. H of -3 is equal to -57. So functional notation is exactly the same as like the evaluation problems that you've been doing when they say evaluate something. And so to demonstrate, they're going to show you a couple of examples of either one, and you'll see that it's the same thing. This one said evaluate this if x is equal to 2. So what you do, you find the answer by replacing x with 2 everywhere, right? So we're going to put 2 here, 2 squared minus 3 times 2. Okay, and then what do you get? Let's do these exponents first and this multiplication. I'll just do it at the same time. So 4 minus 6, that's in the parentheses. And then we do the parentheses first. So 4 minus 6 is -2. Multiply that by 2. And the answer you get is -4. So that's a problem where they said evaluate this, okay? Now, on the next one, they're just going to put it in functional notation. But the problem is the same as the evaluation problem. You're just restating the problem by using functional notation. So if you read this example, the way you would read it is it says, if f of x is equal to this, find f of 2, okay? So now what I would write, if I'm doing the math here, I'm going to write the function down. Here's my machine, x squared minus 3x. This is the f function, or the f machine, whatever. And now I want to find f of 2. F of 2, I'm just going to replace everything with 2. 2 squared minus 3 times 2. This is the same problem as before. Took me a minute to realize that. And then the answer is going to be f of 2, because we already did the math, is equal to negative 4. Okay, and that's the answer. So instead of just writing negative 4 for your answer, the answer is f of 2 is equal to negative 4. All right, let's do another one. Let's just make sure that this is sinking in. Look at him drink that Coke. How did he? Okay, we're going to do this example. And this is example, oh, you know what? I skipped one in the homework. Oh my heck, how did I skip? Did I skip one? No, I didn't skip one. Okay, this just says evaluate this expression if x is equal to negative 2. So once again, we are just going to plug in negative 2 squared. Notice where I put that negative. I put it inside the parentheses. That was the correct way to do it. And then this is going to be 2 times negative 2 minus 1. All right, now we just do the math. Let's do this first. This is the same as negative 2 times negative 2, which is going to be positive 4. And this is going to be the same as 2 times negative 2 is negative 4 minus 1. Negative 4 minus 1 is the same as negative 5. Okay. And then what is 4 times negative 5? It's negative 20, and that's the answer. Bam. You probably like those evaluate this expression better than functions at this point, but functions are going to be important, and I like thinking of them as machines. And you're not a cotton-headed ninny-muggin. Okay, so let's do this g function. This is example 28.7. Oh, this is the last one, so pay attention. If g of x is equal to this, find g of negative 2. Oh, this time we're putting a negative 2 into the machine. Why would you do that? You're gonna gum up the machine. All right, let's write it. G of negative 2. I'm just going to plug in negative 2 everywhere. And you can see that this is exactly the same as the previous problem. But instead of the answer that I got before, I'm going to write g of negative 2 is equal to negative 20, because we already did that math. But this is how you would write it. G of negative 2 is equal to negative 20. It's tricky, right? Because it looks like you might need to solve for g, but that's not what this means. This means I'm putting negative 2 into that function of g. All right, cool. And guess what? You did it. You did it, Addie. Good job getting through your math lesson today. Love you, Addie. Bye.